Brought to you by WikiVidi documentaries. Boeing B-52 Stratofortress. The Boeing B-52 Stratofortress is an American long-range, subsonic, jet-powered strategic bomber. The B-52 was designed and built by Boeing, which has continued to provide support and upgrades. It has been operated by the United States Air Force since the 1950s. The bomber is capable of carrying up to 70,000 pounds of weapons, and has a typical combat range of more than 8,800 miles without aerial refueling. Beginning with a successful contract bid in June 1946, the B-52 design evolved from a straight-wing aircraft powered by 6 turboprop engines, to the final prototype B-52 with 8 turbojet engines and swept wings. The B-52 took its maiden flight in April 1952. Built to carry nuclear weapons for Cold War-era deterrence missions, the B-52 Stratofortress replaced the Convair B-36. A veteran of several wars, the B-52 has dropped only conventional munitions in combat. The B-52's official name Stratofortress is rarely used. Informally, the aircraft has become commonly referred to as the Buff. The B-52 has been in active service with the USAF since 1955, 58 were in active service with 18 in reserve. The bombers flew under the Strategic Air Command until it was disestablished in 1992, and its aircraft absorbed into the Air Combat Command. In 2010 all B-52 Stratofortresses were transferred from the ACC to the newly created Air Force Global Strike Command. Superior performance at high subsonic speeds and relatively low operating costs have kept the B-52 in service despite the advent of later, more advanced aircraft, including the cancelled Mach 3 B-70 Valkyrie, the variable geometry B-1 Lancer, and the stealth B-2 Spirit. The B-52 completed 60 years of continuous service with its original operator in 2015. After being upgraded between 2013 and 2015, it is expected to serve into the 2050s. The B-52s are expected to reach the end of their service lives by 2045, and be replaced by B-21 Raiders. Origins. On the 23rd of November 1945, Air Materiel Command issued desired performance characteristics for a new strategic bomber capable of carrying out the strategic mission without dependence upon advanced and intermediate bases controlled by other countries. The aircraft was to have a crew of 5 or more turret gunners, and a 6-man relief crew. It was required to cruise at 300 miles per hour at 34,000 feet, with a combat radius of 5,000 miles. The armament was to consist of an unspecified number of 20mm cannon and 10,000 pounds of bombs. On the 13th of February 1946, the Air Force issued bid invitations for these specifications, with Boeing, Consolidated Aircraft, and Glenn L. Martin Company submitting proposals. On the 5th of June 1946, Boeing's Model 462, a straight-wing aircraft powered by 6 Wright T-35 turboprops with a gross weight of 360,000 pounds and a combat radius of 3,110 miles, was declared the winner. On the 28th of June 1946, Boeing was issued a letter of contract for $1.7 million to build a full-scale mock-up of the new B-52 and do preliminary engineering and testing. However, by October 1946, the Air Force began to express concern about the sheer size of the new aircraft and its inability to meet the specified design requirements. In response, Boeing produced Model 464, a smaller 4-engine version with a 230,000-pound gross weight, which was briefly deemed acceptable. Subsequently, in November 1946, the Deputy Chief of Air Staff for Research and Development, General Curtis LeMay, expressed the desire for a cruise speed of 400 miles per hour, to which Boeing responded with a 300,000 pounds aircraft. In December 1946, Boeing was asked to change their design to a 4-engine bomber with a top speed of 400 miles per hour, range of 12,000 miles, and the ability to carry a nuclear weapon. In total, the aircraft could weigh up to 480,000 pounds. Boeing responded with 2 models powered by T-35 turboprops. The Model 464-16 was A, nuclear only, bomber with a 10,000-pound payload, while the Model 464-17 was a general-purpose bomber with a 9,000-pound payload. Due to the cost associated with purchasing two specialized aircraft, the Air Force selected Model 464-17, with the understanding that it could be adapted for nuclear strikes. In June 1947, the military requirements were updated, and the Model 464-17 met all of them except for the range. It was becoming obvious to the Air Force that, even with the updated performance, the B-52 would be obsolete by the time it entered production and would offer little improvement over the Convair B-36. As a result, the entire project was postponed for 6 months. During this time, Boeing continued to perfect the design, which resulted in the Model 464-29, with a top speed of 455 miles per hour and a 5,000-mile range. In September 1947, the Heavy Bombardment Committee was convened to ascertain performance requirements for a nuclear bomber. Formalized on the 8th of December 1947, these requirements called for a top speed of 500 miles per hour and an 8,000-mile range, far beyond the capabilities of 464-29. The outright cancellation of the Boeing contract on the 11th of December 1947 was staved off by a plea from its president William McPherson Allen. To the Secretary of the Air Force Stuart Symington, Allen reasoned that the design was capable of being adapted to new aviation technology and more stringent requirements. In January 1948, Boeing was instructed to thoroughly explore recent technological innovations, including aerial refueling and the flying wing. Noting stability and control problems Northrop was experiencing with A-35 and U-49 flying wing bombers, Boeing insisted on a conventional aircraft, and in April 1948 presented a $30 million proposal for design, construction, and testing of two Model 464-35 prototypes. Further revisions during 1948 resulted in an aircraft with a top speed of 513 miles per hour at 35,000 feet, a range of 6,909 miles, and a 280,000 pounds gross weight, which included 10,000 pounds of bombs and 19,875 US gallons of fuel. Design effort. In May 1948, AMC asked Boeing to incorporate the previously discarded, but now more fuel-efficient, jet engine into the design. That resulted in the development of yet another revision. In July 1948, Model 464-40 substituted Westinghouse J-40 turbojets for the turboprops. The Air Force project officer who reviewed the Model 464-40 was favorably impressed, especially since he had already been thinking along similar lines. Nevertheless, the government was concerned about the high fuel consumption rate of the jet engines of the day, and directed that Boeing still use the turboprop-powered Model 464-35 as the basis for the B-52. Although he agreed that turbojet propulsion was the future, General Howard A. Craig, Deputy Chief of Staff for Material, was not very keen on a jet-powered B-52, since he felt that the jet engine had not yet progressed sufficiently to permit skipping an intermediate turboprop stage. However, Boeing was encouraged to continue turbojet studies even without any expected commitment to jet propulsion. On Thursday, the 21st of October 1948, Boeing engineers George S. Shire, Art Carlson, and Vaughn Blumenthal presented the design of a 4-engine turboprop bomber to the Chief of Bomber Development, Colonel Pete Worden. Worden was disappointed by the projected aircraft and asked if the Boeing team could come up with a proposal for a 4-engine turbojet bomber. Joined by Ed Wells, Boeing Vice President of Engineering, the engineers worked that night in the Hotel Van Cleve in Dayton, Ohio, redesigning Boeing's proposal as a 4-engine turbojet bomber. On Friday, Colonel Worden looked over the information and asked for a better design. Returning to the hotel, the Boeing team was joined by Bob Withington and Maynard Pennell, two top Boeing engineers who were in town on other business. By late Friday night, they had laid out what was essentially a new airplane. The new design built upon the basic layout of the B-47 Stratojet with 35-degree swept wings, 8 engines paired in 4 underwing pods, and bicycle landing gear with wingtip outrigger wheels. A notable feature of the landing gear was the ability to pivot the main landing gear up to 20 degrees from the aircraft's centerline to increase safety during crosswind landings. After a trip to a hobby shop for supplies, Shah set to work building a model. The rest of the team focused on weight and performance data. Wells, who was also a skilled artist, completed the aircraft drawings. On Sunday, a stenographer was hired to type a clean copy of the proposal. On Monday, Shire presented Colonel Warden with a neatly bound 33-page proposal and a 14-inch scale model. The aircraft was projected to exceed all design specifications. Although the full-size mock-up inspection in April 1949 was generally favorable, range again became a concern, since the J-40S and early model J-57S had excessive fuel consumption. Despite talk of another revision of specifications, or even a full design competition among aircraft manufacturers, General LeMay, now in charge of Strategic Air Command, insisted that performance should not be compromised due to delays in engine development. In a final attempt to increase range, Boeing created the larger 464-67, stating that once in production, the range could be further increased in subsequent modifications. Following several direct interventions by LeMay, Boeing was awarded a production contract for 13 B-52As and 17 detachable reconnaissance pods on 14 February 1951. The last major design change, also at General LeMay's insistence, was a switch from the B-47-style tandem seating to a more conventional side-by-side cockpit, which increased the effectiveness of the co-pilot and reduced crew fatigue. Both ex-B-52 prototypes featured the original tandem seating arrangement with a framed bubble-type canopy. Pre-production and production. The B-52, the second ex-B-52 modified with more operational equipment, first flew on 15 April 1952 with Tex Johnston as pilot. During ground testing on 29 November 1951, the ex-B-52's pneumatic system failed during a full pressure test. The resulting explosion severely damaged the trailing edge of the wing, necessitating considerable repairs. A 2-hour, 21-minute proving flight from Boeing Field, King County, in Seattle, Washington to Larson AFB was undertaken with Boeing test pilot Johnston and Air Force Lieutenant Colonel Guy M. Townsend. The ex-B-52 followed on 2 October 1952. The thorough development, including 670 days in the wind tunnel and 130 days of aerodynamic and aeroelastic testing, paid off with smooth flight testing. Encouraged, the Air Force increased its order to 282 B-52s. Only 3 of the 13 B-52s ordered were built. All were returned to Boeing and used in their test program. On 9 June 1952, the February 1951 contract was updated to order the aircraft under new specifications. The final 10, the first aircraft to enter active service, were completed as B-52Bs. At the rollout ceremony on 18 March 1954, Air Force Chief of Staff General Nathan Twining said, "The B-52B was followed by progressively improved bomber and reconnaissance variants, culminating in the B-52G and turbofan B-52H. To allow rapid delivery, production lines were set up both at its main Seattle factory and at Boeing's Wichita facility. More than 5,000 companies were involved in the massive production effort, with 41% of the airframe being built by subcontractors. The prototypes and all B-52A, B and C models were built at Seattle. Testing of aircraft built at Seattle caused problems due to jet noise, which led to the establishment of curfews for engine tests. Aircraft were ferried 150 miles east on their maiden flights to Larson Air Force Base near Moses Lake, where they were fully tested. As production of the B-47 came to an end, the Wichita factory was phased in for B-52D production, with Seattle responsible for 101D models and Wichita 69. Both plants continued to build the B-52E, with 42 built at Seattle and 58 at Wichita, and the B-52F. For the B-52G, it was decided in 1957 to transfer all production to Wichita, which freed up Seattle for other tasks. Production ended in 1962 with the B-52H, with 742 aircraft built. plus the original 2 prototypes. Upgrades. A proposed variant of the B-52H was the B-52H, which would have consisted of 16 modified and augmented B-52H airframes with additional electronic jamming capabilities. This variant would have restored USAF airborne jamming capability that it lost on retiring the F-111 Raven. The program was cancelled in 2005 following the removal of funds for the standoff jammer. The program was revived in 2007 and cut again in early 2009. In July 2013, the Air Force began a fleet-wide technological upgrade of its B-52 bombers called Combat Network Communications Technology to modernize electronics, communications technology, computing, and avionics on the flight deck. Connect upgrades include software and hardware such as new computer servers, modems, radios, data links, receivers, and digital workstations for the crew. One update is the ARC-210 Warrior Beyond line-of-sight software programmable radio able to transmit voice, data, and information in flight between B-52s and ground command and control centers, allowing the transmission and reception of data with updated intelligence, mapping, and targeting information. Previous in-flight target changes required copying down coordinates. The ARC-210 allows machine-to-machine transfer of data, useful on long-endurance missions, where targets may have moved before the arrival of the B-52. The aircraft will be able to receive information through Link 16. Connect upgrades will cost $1.1 billion overall and take several years. Funding has been secured for 30 B-52s. The Air Force hopes for 10 Connect upgrades per year, but the rate has yet to be decided. Weapons upgrades include the 1760 Internal Weapons Bay upgrade, which gives a 66% increase in weapons payload using a digital interface and rotary launcher. IBU is expected to cost roughly $313 million. The 1760 IBU will allow the B-52 to carry the AGM-158B JASMIR cruise missile and the ADM-160C Maul J decoy missile. All 1760 IBUs should be operational by October 2017. 2 bombers will have the ability to carry 40 weapons in place of the 36 that 3 B-52s can carry. The 1760 IBU allows precision-guided missiles or bombs to be deployed from inside the weapons bay. Previous aircraft carried these munitions externally on wing hardpoints. This increases the number of guided weapons a B-52 can carry and reduces the need for guided bombs to be carried on the wings. The first phase will allow a B-52 to carry 24 500-pound guided JDAM bombs or 22,000-pound JDAMs, with later phases accommodating the Jasmine Mauled family of missiles. In addition to carrying more smart bombs, moving them internally from the wings reduces drag and achieves a 15% reduction in fuel consumption. Air Force scientists are working to arm the B-52 with defensive laser weapons able to incinerate attacking air-to-air or surface-to-air missiles. Overview. The B-52 shared many technological similarities with the preceding Boeing B-47 Stratojet strategic bomber. The 2 aircraft used the same basic design, such as swept wings and podded jet engines, and the cabin included the crew ejection systems. On the B-52D, the pilots and electronic countermeasures operator ejected upwards, while the lower deck crew ejected downwards. Until the B-52G, the gunner had to jettison the tail gun to bail out. Structural fatigue was accelerated by at least a factor of 8 in a low-altitude flight profile over that of high-altitude flying, requiring costly repairs to extend service life. In the early 1960s, the 3-phase high-stress program was launched to counter structural fatigue, enrolling aircraft at 2,000 flying hours. Follow-up programs were conducted, such as a 2,000-hour service life extension to select airframes in 1966-1968. And the extensive Pacer plank reskinning, completed in 1977. The wet wing introduced on G and H models was even more susceptible to fatigue, experiencing 60% more stress during flight than the old wing. The wings were modified by 1964 under ECP 1050. This was followed by a fuselage, skin, and longerong replacement in 1966, and the B-52 Stability Augmentation and Flight Control Program in 1967. fuel leaks due to deteriorating Marmon clamps continued to plague all variants of the B-52. To this end, the aircraft was subjected to blue band, hard shell, and finally quick clip programs. The latter fitted safety straps that prevented catastrophic loss of fuel in case of clamp failure. The B-52's service ceiling is officially listed as 50,000 feet, but operational experience shows this is difficult to reach when fully laden with bombs. According to one source, the optimal altitude for a combat mission was around 43,000 feet, because to exceed that height would rapidly degrade the plane's range. In September 2006, the B-52 became one of the first U.S. military aircraft to fly using alternative fuel. It took off from Edwards Air Force Base with a 50-50 blend of Fischer-Tropsch process synthetic fuel and conventional JP-8 jet fuel, which burned in 2 of the 8 engines. On the 15th of December 2006, a B-52 took off from Edwards with the synthetic fuel powering all 8 engines, the first time an Air Force aircraft was entirely powered by the blend. The 7-hour flight was considered a success. This program is part of the Department of Defense Assured Fuel Initiative, which aims to reduce crude oil usage and obtain half of its aviation fuel from alternative sources by 2016. On the 8th of August 2007, Air Force Secretary Michael Wynne certified the B-52H as fully approved to use the FT blend. Flight controls. Because of the B-52's mission parameters, only modest maneuvers would be required with no need for spin recovery. The aircraft has a relatively small, narrow-chord rudder, giving it limited yaw control authority. Originally an all-moving vertical stabilizer was to be used, but was abandoned because of doubts about hydraulic actuator reliability. Because the aircraft has 8 engines, asymmetrical thrust due to the loss of an engine in flight would be minimal and correctable with the narrow rudder. To assist with crosswind takeoffs and landings, the main landing gear can be pivoted 20 degrees to either side from neutral. This yaw-adjustable crosswind landing gear would be preset by the crew according to wind observations made on the ground. The elevator is also very narrow and chord like the rudder, and the B-52 suffers from limited elevator control authority. For long-term pitch trim and speed changes, the aircraft chooses an all-moving tail with the elevator used for small adjustments within a stabilizer setting. The stabilizer is adjustable through 13 degrees of movement and is crucial to operations during takeoff and landing due to large pitch changes induced by flap application. B-52s prior to the G models had very small ailerons with a short span that was approximately equal to their chord. These feeler ailerons were used to provide feedback forces to the pilot's control yoke and to fine-tune the roll axes during delicate maneuvers such as aerial refueling. Due to twisting of the thin main wing, conventional outboard flat-type ailerons would lose authority and therefore could not be used. In other words, aileron activation would cause the wing to twist, undermining roll control. 6 spoilerons on each wing are responsible for the majority of roll control. The late B-52G models eliminated the ailerons altogether and added an extra spoileron to each wing. Partly because of the lack of ailerons, the B-52G and H models were more susceptible to Dutch roll. Brought to you by WikiVidi documentaries. Would you like to know more?